in our previous example, when we talked about structs, we had a struct called point, and that struct had the x and y coordinates expressed as f32 values. Or was it f64? I can't remember. Maybe f64. So the struct is very good. It's very useful for us. However, there is a bit of a problem, because let's suppose that we want to make a point out of different data types. Let's suppose that we want to have integral values as x and y coordinates. What if we want f32 values instead? Well, in this case, what we can do is we can leverage the power of generics, which let us not specify the exact type that we're using for the elements of point. So let me make a function called generics here. And that's where we're going to do our demo. So I don't want to specify explicitly what the type of the coordinate is. In this case, I can add a generic parameter called t, and it's added like this. So instead of just a struct point, it becomes point of t. We've already seen some of the t types. For example, option of t is an optional value of type t. And here we have a point struct, which instead of using f64 for the x and y coordinates, it's going to use the type t. So now essentially what we can do is we can define a point using either integers or floating point numbers, just about anything. You're basically going to get the x and y fields, but their type is not defined. So we can say let a equals point, x is equal to 0, and y is equal to 0. So we have some integral values here, or we can state, for example, that we have a point using x 1.2, so that would be a floating point value, and the same goes for y, so 3.4, for example. So this this particular structure is actually a point of I32, for example. So we can, if we want to be explicit about the type, we can say let point a point of I32, and we can say here that this is a point of f64, for example. So this is going to compile just fine. I haven't got any output here yet. However, what I can also do is I can, for example, say that this is going to be an unsigned U16, for instance. And in this case, the values 0 and 0 here, and I could change it to some other integral value, are going to be treated as U16 values for the purposes of initialization. Once again, everything compiles just fine, and it works just fine. So essentially, you can make a point with any type x and y, and indeed you can specify different types for x and y. So you can add another type parameter v here, and you can say that v is going to be used for the y coordinate here. So essentially I can say that the x is going to be a u16 and the y is going to be an I32, and this will work just fine. Obviously the second case would have to be changed to something else, like two f64s. In this case it compiles just fine, but of course thanks to Rust type deduction you can basically get rid of these things for most cases, and it will just try to guess the most obvious type in given the data that you're trying to feed it, meaning that at the moment a is made up of I32s. If I put like a 0.3 in here, then t is going to be an f64 and y will continue being an I32. So this is how the whole thing works. Now what we can also do is we can sort of extend this to structs which use this struct. So let's jump back to a situation where we just had a single t variable here. Now what I can do is I can define a line. So once again I can make a struct called line, and the line will also take a type parameter t, and the line can be composed of 2 points, start and end. Both of them are point t fields effectively. So end is a point t. Now the issue here is that this t has to match this t. They have to be the same type. So essentially if I have, let's say I have 0, 4 here and 1.2, 3.4 here, I will not be able to construct a line. So I cannot say let my line equals line with a and b. So I cannot say that start is a and end is b. And the reason I cannot do this is because the type of a is going to be point I32 and the type of b is point f64, so we will not be able to combine those into a single t. And if I try to compile this, you'll see that, well, first of all, there's a wrong number of arguments here, because point must have a type parameter, so we can get rid of the the point type altogether because it's deduced from the right-hand side. But now if I try to compile this, I get mismatched types. You'll notice it underlines the B. So it basically says that the end should match the beginning. And so what I can do here is I can specify that this is a point of f64, for example, and in this case we're going to be just fine with the whole thing, except that now, of course, these values also should be somehow adapted to f64. So you can either write not like so, or you can turn the integer 4 into an f64 just by putting f64 towards the end, and this is fine. This compiles and we get no output, but you can see that it works fine. So the whole point of generics is that instead of specifying rigidly what the type is, you can basically say, oh, this is going to be a vector of any value. And you can have several of those types defined, and you can use them right inside the struct.